3. The secondary nebular stage. The enormous nebula now began gradually to assume the spiral form and to become clearly visible to the astronomers of even distant universes. This is the natural history of most nebulae. Before they begin to throw off suns and start upon the work of universe building, these secondary space nebulae are usually observed as spiral phenomena. The nearby star students of that faraway era, as they observed this metamorphosis of the Andronover Nebula, saw exactly what 20th century astronomers see when they turn their telescopes spaceward and view the present-age spiral nebulae of adjacent outer space. About the time of the attainment of the maximum of mass, the gravity control of the gaseous content commenced to weaken, and there ensued the stage of gas escapement, the gas streaming forth as two gigantic and distinct arms, which took origin on opposite sides of the mother mass. The rapid revolutions of this enormous central core soon imparted a spiral appearance to these two projecting gas streams. The cooling and subsequent condensation of portions of these protruding arms eventually produced their knotted appearance. These denser portions were vast systems and subsystems of physical matter whirling through space in the midst of the gaseous cloud of the nebula while being held securely within the gravity grasp of the mother wheel. But the nebula had begun to contract, and the increase in the rate of revolution further lessened gravity control, and ere long the outer gaseous regions began actually to escape from the immediate embrace of the nebular nucleus, passing out into space on circuits of irregular outline, returning to the nuclear regions to complete their circuits, and so on. But this was only a temporary stage of nebular progression. The ever-increasing rate of whirling was soon to throw enormous suns off into space on independent circuits. And this is what happened in Andronover ages upon ages ago. The energy wheel grew and grew until it attained its maximum of expansion, and then, when contraction set in, it whirled on faster and faster until, eventually, the critical centrifugal stage was reached, and the great breakup began. 500 billion years ago, the first Andronover sun was born. This blazing streak broke away from the mother gravity grasp and tore out into space on an independent adventure in the cosmos of creation. Its orbit was determined by its path of escape. Such young suns quickly become spherical and start out on their long and eventful careers as the stars of space. Excepting terminal nebular nucleuses, the vast majority of Orvontan suns have had an analogous birth. These escaping suns pass through varied periods of evolution and subsequent universe service. 400 billion years ago began the recaptive period of the Andronover Nebula. Many of the nearby and smaller suns were recaptured as a result of the gradual enlargement and further condensation of the mother nucleus. Very soon there was inaugurated the terminal phase of nebular condensation, the period which always precedes the final segregation of these immense space aggregations of energy and matter. It was scarcely a million years subsequent to this epoch that Michael of Nebadon, a creator son of Paradise, selected this disintegrating nebula as the site of his adventure in universe building. Almost immediately the architectural worlds of Salvington and the 100 constellation headquarters groups of planets were begun. It required almost 1 million years to complete these clusters of specially created worlds. The local system headquarters planets were constructed over a period extending from that time to about 5 billion years ago. 300 billion years ago, the Andronover solar circuits were well established, and the nebular system was passing through a transient period of relative physical stability. About this time, the staff of Michael arrived on Salvington, and the Aversa government of Orvontan extended physical recognition to the local universe of Nebadon. 200 billion years ago witnessed the progression of contraction and condensation with enormous heat generation in the Andronover central cluster, or nuclear mass. Relative space appeared even in the regions near the central mother wheel. The outer regions were becoming more stabilized and better organized. Some planets revolving around the newborn suns had cooled sufficiently to be suitable for life implantation. The oldest inhabited planets of Nebadon date from these times. Now the completed universe mechanism of Nebadon first begins to function, and Michael's creation is registered on Uversa as a universe of inhabitation and progressive mortal ascension. 100 billion years ago, the nebular apex of condensation tension was reached. The point of maximum heat tension was attained. This critical stage of gravity-heat contention sometimes lasts for ages, but sooner or later, heat wins the struggle with gravity, and the spectacular period of sun dispersion begins, and this marks the end of the secondary career of a space nebula.